So hello guys, today we are going to see cloud reference model in cloud computing, where there are many services such as SaaS, IAAS, IaaS, and PAAS PaaS. These services comprise into the cloud computing reference model. So we will also look at in detail and descriptive ways, also illustrations and images we will use to understand what are these models, how these work, and also much more things in detail. So let's start. So what is a cloud reference model? Cloud reference model is a key model, to understanding cloud computing. In cloud reference model, you can see it composed of services, and these services are clustered together in the form of groups, which represents what a particular category of service a group is being giving. These groups are important to understand, categorize, and build cloud computing reference model. So these groups are mainly three three groups. So where you can see infrastructure as a service, platform as a service, and software as a service. These three main groups makes the cloud reference model uh, possible. So these three groups comprise of many technologies. Each group comprises of many different technology, and these three groups combined together creates cloud reference model. And these three groups each has a different technologies, services, and parameters are enlisted to them. So let's first we will discuss the diagram, what the diagram tells us about the cloud computing reference model. So first we have interaction with IaaS, PaaS, and SaaS services via Web 2.0. If you ask what is Web 2.0, Web 2.0 is a basically interacting version of new web world, where there is no more static pages but dynamic pages, and it allows social media to create, publish, and share their user generated content, including blogs and posts and videos, images, to the websites, and have a dynamic interaction with the user. uh, and it takes inputs, it gives outputs, and have a dynamic and enrich user interface with it. So that's Web 2.0. So that's Web 2.0 lets us possible use this cloud computing services and cloud based systems. Before 2.0, there is no interaction or any kind of services which we can utilize or have interaction with the web. Those pages are basically static and very cold written, very not very enriched, you can say. On the topmost right side, you can see we have user, businessman, or you can call it a consumer who been consuming all the services via Web 2.0. These business heads will choose the best possible platform for their needs and what their category of businesses which suits their needs and requirements. Many of these business here are many services come into picture. So where is the need, you have to fulfill the need, and there are the many needs of the system. So to fulfill those needs, these services comes into picture. Into the cloud reference model we will look at. So first we are, but before going to the cloud reference model, I want to particularly mention middleware. What is a middleware and what function does middleware does? So let's first look at middleware. So I want to quickly talk about middleware. So let's look at it. Middleware manages interaction between application software and underlying system software layers, such as operating system and device driver layers, as well as application residing across network devices. So middleware is basically internal layer which manages the interaction of your software developed, or a service you've been using, handling those requests from software to internal system software, operating system, which communicates with hardware via kernel. So that's what really actually it is. So middleware allows you to communicate with the hardware, take the resources, such as your files, system files, audio, video, on any documents. All these systems are being gone through middleware. Middleware, exposes APIs and other system libraries to the developer, so he can develop his apps to the platform or IaaS or SaaS services. So let's read further. Data management, application services, messaging, authentication, and application programming interface APIs management are all commonly handled by middleware. So these are the functions and jobs of the middleware to manage data management, application services, messaging, authentications. These are the most of the services. Middleware is mostly utilized by utilizing PaaS services, where platform as a service, where you give your platform to the server to serve to the consumer. So where he pays money to you for using the platform, in which here application of this middleware layer we can see PaaS, IaaS, and SaaS systems are three common function. They do this data management, application services, and handling, messaging, authentication, these types of systems. They expose APIs to the resources and to the developer, and all this managing of middleware and hardware, all the systems are uh, uh, done by the service provider. He manages and maintains all the systems. So we should, you know in the conclusion, we should understand what is a middleware. Middleware is simply a software like any other, that is a combination with embedded hardware and other types of embedded software. It is just a simple software that resides between your application you developed and or API or anything you developed or deployed on this cloud computing environment, and the server hardware in between it lies. So now, let's talk about SaaS. So SaaS is a basic stands for software as a service. So at the top of the stack, software as a service solution provides application and service on demand. Most of the common functionalities of desktop applications such as office automation, document management, photo editing, customer relationship management, CRM softwares are replicated on the provider's infrastructure and made more scalable and accessible through browser on demand. These applications are shared across multiple users whose interaction is isolated from other users. The SaaS layer is also the area of social networking websites which leverage cloud-based infrastructure to sustain the load generated by their popularity. So these are the SaaS services we basically do into the systems. So these services are self understanding and self earned. It does not need as much explanation from me. SaaS is basically services provided by service provider which do automation, document management, photo editing, customer relationship management, and other provides infrastructure made for scalable and accessible browser on or through browser on demand. These applications are shared across multiple devices. Social media is a good example of this. So where we should look at, where is SaaS, software as a service, contains end user applications, scientific applications, office automations, and customer relationship management, social networking such as Facebook and other social media platform, Twitter. So now we should look at benefits of SaaS. Accessibility. SaaS applications can be accessed from anywhere with an internet connection, which is ideal for those who works need to access software on the go. Second is a big advantage of is scalability, as SaaS applications are easily scalable up or down as needed, which makes them ideal for businesses, those who need to be adopted quickly to change on demands. Also, big advantage of SaaS services is cost saving. So SaaS applications are typically offered on a subscription basis, on which means that businesses can avoid upfront costs of associated with purchasing and maintaining software, such as There are very famous examples we should look at, such as Google Document, Facebook, Microsoft Office, Dropbox, Zoom. All are the great examples of SaaS we can see. So overall, in conclusion, we should think of SaaS as a services convenient and cost-effective way for a business and individual to access software applications, and they need without the hassle of managing their own infrastructure. So that's all in conclusion what SaaS is: software as a service you are giving to the consumer. Okay, so now let's look at a platform as a service stack. So platform acronym is PAAS, PaaS. So what that's its platform as a service stack. They deliver scalable and elastic runtime environments on demand and host the execution of applications. PaaS services is basically a service where you develop and deploy your applications and run over someone's environment or utilize little framework created by service provider. So create and deploy your own applications on servers. These services are backed. So these services are backed by those service provider. That's what you have to understand from this platform as a service, where you're providing a platform to the user where you can deploy its own applications and own services created by on him, and you giving him a framework or environment to do so. So now let's read further. These services are backed by a core middleware platform that is responsible for creating the abstract environment where applications are deployed and executed. These services are mainly, testing, building and deploy applications on server and utilizing the hardware infrastructure of the company which providing platform as a service. So company which will provide you, so company is going to provide you this basic hardware and software and the middleware there, which allow you to build and deploy your own applications. These are mainly testing, building and scientific computation applications are being developed on the infrastructure, and infrastructure will host the application. So let's read further. It is the responsibility of the service provider to provide scalability and to manage fault tolerances, while users are requested to focus on the logic of the application developed by leveraging the provider's APIs and libraries. This approach increases the level of abstraction at which cloud computing is leveraged, but also constrains the user in a more controlled environment. So here we are saying, so it all the services provider is responsible to manage the platform environment and managing the execution and maintaining of the system. You don't have to worry about it. You don't have to hassle about it. You don't have to think about it. It just that's what you're paying for in this PaaS environment, PaaS system environment. So you just have to develop your applications and services and deploy on the server. Rest of the things managed by the person to handle servers and handling every network request and all other things. Network requests you will handle by the developer, but the internet connection and other uptime such as 99.9% uptime, all these things are related to network are handled by the vendor. All these benefits that you don't have to worry about, underlying infrastructure and managing servers and their needs such as electricity, cooling, fixing runtime environment code and other essentials, all these processes is streamlined and efficient for developer. So that's a big advantage for a developer who is doing from platform as a service, PaaS developer. Main services provided by PaaS developers: runtime environments for applications. So if you want to see what is a runtime environment, runtime environments are being provided by the PaaS service provider, which intended for the developers who create their services on top of the runtime environment. These runtime environments are provide essential tools, framework, technologies, and other libraries needed to develop the application and create a runtime application environment for to run the service or application. Second main advantage of PaaS provider is development and data processing platform. Here we develop a data processing platform, so efficiently and effectively process the big data. Large enterprises, they are also collected their data and other raw crunching of numbers and scientific computing we also does here in the big data development, the data processing platforms. So that's a big advantage of PaaS systems, where platform, you get a platform, and that platform is been, you deploy your large enterprises data to do store there and do number crunching and other scientific applications, collect data or data sorting, all other big things in a big data. If you want to specifically know how data processing does, it is uses collection of data processing, analyzation of data, storing of the data, developing a data platform, creates a a central service that encompasses data warehouses, businesses intelligence tools, and suites of data science and analytical environments. And all these and things are being come under development and data processing platform. That's the second big advantage of a PaaS provider. So what's the best real world example of PaaS are Hadoop, Google App Engine, Windows Azure, IAAS. So these are the big names in the industry, and they provide these services of platform as a service, PaaS. So I think we should look further now. Now let's look at infrastructure as a service, where infrastructure as a service is being provided to the consumer. At the base of the stack, infrastructure as a service solutions deliver infrastructure on demand in the form of virtual hardware, storage, and networking, where virtual hardware is utilized to provide compute on demand in the form of virtual machine instances. So here we, talking about virtual machines, storage, networking on the virtual machine, on the infrastructure of the service provider. So here we can see IaaS comes at the base of the stack, and the name suggests it serves infrastructures as a service to the consumers, where infrastructure provides computing, storage, load balancing, networking such services to its consumers. So now let's look further. uh, these are created and users request on a provider infrastructure, on a provider's infrastructure. So on the infrastructure of a provider, service providers, we create our own virtual machine, we host our own application, we host and store, do networking and other computing jobs on the networks of the infrastructure provided by the service provider. So it is little different from PaaS system. PaaS, where doing only platform as a service, where you have a giving platform to the user, and user developing his own applications and all system deploying on them, and then he using middleware layer to access all the hardware and other systems. Here you giving more deeply, more enriched services such as virtual machines and virtual machines, and also hardware sharing is possible here. So this, let's look at these tools and interfaces to configure the software stack installed in the virtual machine. There's a pricing model which is usually defined in terms of dollar per hour, where the dollar's cost is influenced by characteristics of virtual hardware. So here we can see the infrastructure from Amazon or Microsoft or Google to do our storage computation, perform operations on storage, all these things. These infrastructures, hosted by these companies, and they are the ones who manage them, and from end user we pay for them on a hourly basis, or in some companies you pay for real time money, real time data usage, or the infrastructure usage. So these pricings are mostly real time, and how much you use, that much you pay for it. That's their basic model. And also the virtual machine plays a key role here, as a user has ability to given to change the stack inside the virtual machine. Popular virtual machines VirtualBox where you can run multiple OSs on a single CPU server, and it allows to fully utilize the CPU, thus increasing efficiency of the service. And virtualization also allows you to users to safely and securely compute and use their hardware. Each machine is isolated from each other and allowing greater protection of data. You can't mismanage the data. It also secure and have much deeper uh, data protection in virtualized environments. So I think let's look at further now. Virtual storage is delivered in the form of raw disk space or object store. The former completes a virtual hardware offering that requires persistent storage. The latter is more high level abstraction for storing entities rather than files. Virtual networking identifies the collection of services that manage the networking among virtual instances and their connectivity to the internet or the private network. As we utilize the virtualization, we've been seen in server hardware partition are formed where we have a multiple virtual machines serving and utilizing a single processor, which increases the efficiency and create virtual storage within the virtualization box, which we are utilizing in IaaS services, infrastructure as a service. This makes virtualization to have more abstractions from OS and from VirtualBox. Virtualizations, also involves virtual networking, all the network drivers and networking hardware abstractions, APIs are being virtualization provided to the development suite. All these things managed by the service provider uh, who is giving us the service. Virtualization, networking, and connection to the private network and internet and connections, all this also these things are managed by the service providers. So now let's look at the benefits of IaaS, infrastructure as a service. Infrastructure as a service mostly the main benefits of infrastructure as a service is virtualization, scalability, pay per user based pricing. This makes more you don't have to pay much more upfront cost of the system and much more cheaper access to the newer and other technologies. Virtualization allows you to use many more operating systems, many more storages, and utilize a single CPU to many operating systems and many other services. You can run a single server, which utilization of CPU is maximum, and you pay for much cheaper prices. Scalability, you also achieve in infrastructure as a service scalability, where you scale the system to the utmost flexibility, where if your users rank up too much quickly, you can easily add more infrastructure, add more stacks, do horizontal or vertical scaling of the system. You don't have to worry about other uh, mm, other system such as system failures, such as user input uh, increases, so system will not hang or system will not take any actions or to deny the service, deny the services. These are basically managed by the service provider to easily scale up the system, to easily scale up the websites, easily scale up your applications and services according to your user input. API. So also the fourth benefit of IaaS is API driven infrastructure. Here we can see APIs are being exposed to the user by IaaS infrastructure, which allows users to automate management of their infrastructure. So these are the couple of benefits of IaaS we can see here. So these main benefits you know are the, you can see, core thing of uh, IaaS infrastructure as a service, which separates from platform as a service and software as a service. So these are the three main things. And middleware, this middleware is common between all these three. So these three things make cloud computing possible and cloud computing reference model possible. So I think you understood now what's it all about it, how cloud reference model works, and how these things basically makes uh, work in their own category, SaaS, IaaS, PaaS services. So I think we should stop now. So thank you to listening till end. Thank you so much.